Hi all, so this is Shikha from Technical Cloud Knowledge and I'm back with another lecture on Linux. So as you can see, this is the lecture number 45 on Linux and today we will take a deeper look at the video concept in Linux. One more thing which I would like to discuss with you, and that is I would like to point out that it is a very advanced level on storage management and the very advanced topic on storage management, that is video concept. So for that, I recommend you all that you should watch the entire video until the very end so that you will not going to miss any important information regarding the video concept. So let's have a look without wasting our time. So first I'll take you with the overview of the previous thing which we have done with like the traditional method of partitioning of your hard drive and the second method which is our LVM concept. Okay, we'll first have an overview regarding both of them. Okay. So basically what we were doing under the traditional method, so basically suppose this is your system, okay, and on which you have set up a hard drive. And let's assume this hard drive named as SGB, which is of 500 GB. 500 GB. Now what happens? Under the traditional method, what we were doing, we are simply formatting this hard drive. So suppose we are formatting this hard drive with ext2 file system. Thereafter, what we are doing? So thereafter, we are mounting up this hard drive with the directory. So suppose we have created a directory named as India and then we have mounted this hard drive named as SGB with the India directory which has 100 files of data. Okay, so now this 100 files of data is directly going to the SDB hard drive for the storage. Okay, so this is the basically the main method of traditional which we were using, but we have converted to or we have diverted to LVM concept because we can't append or extend our data or hard drive size runtime. That's why we are moved to the LVM concept, because there is no such kind of a option in which we can extend our hard drive size runtime. In which type of situation we need to set up another hard drive, we need to format this hard drive, and then we need to save the data again in this new hard drive. So basically this is the concept. That's why we moved with the second concept, which is our LVM concept. So if I talk about the LVM concept, under the LVM concept, what we were doing, we are setting up a system on which we are setting up a hard drive. Okay, so suppose this is your hard drive named as SDB and which is also of 500 GB. Now what we were doing, basically this hard drive, we are converting this hard drive into a PV under the LVM concept. Okay, so suppose we have converted this hard drive into a PV under dev directory. We have converted this hard drive into a PV. Afterwards, what we have done, basically, then we will going to add up this hard PV into a VG. Okay, so for that we will create a volume group. So suppose I have created a volume group named as my VG. Thereafter, what we were doing, so basically afterwards we are creating LV from this VG only. So for that I have created a LV named as LV1. Okay, and which is of, let's take it that we have created it under 5G. Okay, afterwards we'll format this LV. So suppose I have formatted this LV with the ext2 file system, and thereafter I am creating a directory named as same directory, which is India. Okay, we are formatting. So suppose we have created a directory India and it has also the same sort of data, which is 100 files. Now our data of India directory is directly mounted up with the LV1. So basically our India directory data is directly going to the LV1. Okay, logical volume. Now what happens if we want to extend our LV size runtime, or if we want to extend our VG size runtime, how we can do so? We do not need to worry much. Okay, in this type of situation, we will simply set up, or we will simply add up a new hard drive here. We'll convert that hard drive into a PV. Wait a minute. We'll convert this hard drive into a PV, and thereafter we'll add up this PV into the volume group. So suppose we have set up a hard drive named as SGC and we have converted this SGC hard drive into a PV. Afterwards we have added this hard drive into our, or we have extended our VG by adding up SGC PV, so that we are able to, or so that we are easily able to extend our VG size and we can extend it runtime. and also we are able to save our data. Okay, so this is the LVM concept and the traditional method concept, but they both have a drawback. The drawback is that suppose if we have the same sort of data, we are saving the same data in different folders, and it is also using the some sort of storage. It will also using the disk space. Okay, without confirming with us that the same storage space or using that you are duplicating the same data. Okay, so in such type of situation they have the drawback, they are saving the same data, the duplicate data, without eliminating the data. So that's why the video concept is came in the market to save our disk space. How we can do so? So let's understand the video concept in a better way so that you will able to understand what I'm saying. Okay, so video concept, basically video is referred to virtual data optimizer. What is virtual data optimizer? Basically, as the name is suggesting, it will optimize, it will save your data virtually. Basically what happens, video, it is a kind of, you can also say a block optimizer, or it is a kind of a kernel module that is used to save disk space, okay, and reduce the replication. Basically what happens, if you have the same data, if you are copying the same data into many folders, so it will reduce the replications. Okay, it will reduce the replication of duplicate copies. It will eliminate these duplicated copies and will save into a single copy. So this is your video concept which will save your disk space. So if I talk about the features of video, it has three features. The very first is your zero block elimination. The second one is your deduplication, and the third one is your compression. Let's understand these three features. Okay, just a minute. So the first feature is your zero block elimination. Let's understand the zero block elimination first. What is zero block elimination? Let me make you understand through an example for a better understanding. Okay, suppose I have a mug of water in which I have dissolved, or in which I have mixed the sand. Now I want to filter the sand particles only, remaining the water. I just want the sand particles. Okay, rest of the water. So how we can do so? So if you do remember that when you were children, you know that to filter anything, or if we want to filter the liquid and the solid particles, we'll use the science concept, which is the filtering concept. Okay, so how we can do so? So basically for that we'll use the filter paper. It will filter the sand particles, the solid particle, and the water remaining your mug. So okay, the water will remain in under your mug and you will able to filter the sand particles. So we'll do so this type of situation. So similarly, under the video concept, video will filter out the zero block eliminations. What will do video? Basically suppose this is your mug of blocks. Okay, your mug of blocks, or should I say the boxes. Okay, so this is your mug of blocks which has been filled that much. Let's make some blocks here. Okay, now what will happen? Video will filter out, assume one more thing, that assume this one, this. Okay, so assume this ones are filled with the data or the information. Okay, now the other ones, as you can see here, these ones which are not filled with anything, these are your zero block. Okay, zero block which is not filled, which is empty. So what will virtual data optimizer do? So video will remove these kind of data blocks, okay, and will remove these kind of data block, eliminate zero block, okay, which do not have any information or which do not have any sort of data. So it will only save such kind of blocks which have some kind of information, or the data will have something which have something. It will only save such kind of blocks. Okay, and the further blocks which is not in use or which is empty, it will remove that blocks. So this happens under the zero block elimination. So if I talk about the second features of video is that your deduplication. So deduplication is very simple. Basically what happens under the deduplication method is that it is a kind of a feature, or you can say a software feature, that is used to remove the duplicate copies of the same data. Okay, suppose if you have ABC, if you have the data of ABC file, okay, now you have saved ABC files of data which has 100 files. Okay, a folder named as ABC which has 100 files, and you have saved this data into many folders. Like under the India directory you have saved this data, under the cloud directory, under the AWS directory. Okay, so what you have done basically, you have save the same data, duplicate copies of the ABC files into many folders. So what will happen under the deduplication method of video? It will remove or it will eliminate the duplicate entries and will convert into a single copy of the data. So this is your deduplication. The third feature is your compression, as the name is also suggesting. So basically what happens in the compression method, if you are copying or if you are saving the same sort of data into many folders, so it will compress this data and will provide a reference number which is the same reference number. And if you are saving the same data into many folders, so it will save the data into one single copy within a compressed folder, okay, within a compressed size. So suppose if your data is of 5 GB, so it will compress it into around in few MBs or in 1 GB. Okay, so that's how the compression method will work. So these three are your video features. Okay, so video will provide you these three features for the better concept, for the better systematically structure. Now one more thing which I would like to discuss with you, that regarding the space. So video also provide you two types of space. Okay, video will provide you two type of space. The very first is your physical space. Okay. The second is your logical space. Now let's understand the physical and the logical space. Basically, what is physical space? Physical space is such type of space which is used by the admins. Okay, admins who create the video, admins who create the LV, okay, who set up the hard drive. So these are the admins who use this physical space. The second is logical space. It is used by the customers. Customers, whom are the customer? Basically those customers who read your data, who will use your data. Okay, so these are the customers. So basically under the physical space, what happens? Suppose if you have set up a hard drive of 500 GB. Okay, now what happens if you add or if you reduce anything, or if you like, suppose if you have extended the data of 100 files into your hard drive, so there is no such kind of a backend storage of hard drive will affect. It will still remaining 500 GB. Okay, and suppose if you reduce 50 files from your data, so there is no such effects on your hard drive storage. It will still 500 GB. So this is known as your physical space. When there is no such kind of a adverse effect of your storage space, so it will refer to your physical space. Just your logical space will get extended and reduced. So this is your logical space which will see by the customers, okay, which the customers can see that your storage space is getting reduced or extended. Okay, so this is your logical space when you reduce or extend your storage space. Okay, now what I'm saying, basically suppose in the runtime, if you are extended some sort of data into a directory, so your logical space would get also get extended, but if you're reducing it, so your logical space is also get reduced. But there is no such kind of a effect on physical space. You'll get to understand this in a better way when you will do the practical. Okay, so for the practical, we'll do it in the further lecture, in the next lecture of video concept. Today we'll just cover up the conceptual base of video concept. Okay, and I hope you will able to understand the concept of a video, why we are using video here for the deduplication method and for the compression method. Okay, so this is your lecture of today's class. Okay, and yeah, so let's wind up here, and thanks for watching.